Namaste children. Already we have seen yesterday that the definition of reflection. Now today we are going to learn about reflection and refraction definition and how the reflection takes place in spherical mirrors. What is light? Light is a form of energy that enables us to see things. Light starts from a source. That source is called as luminous bodies and bounces off objects which are perceived by our eyes. After bouncing back, it is known as the phenomenon of reflection. That reflected light is perceived by our eyes and we can able to see the things that whatever it is perceiving by the eyes, the optic nerve converts them into electrical signals and sends to our brain. Then brain processes that signal and sends back the answer, the response, so that we can able to see the things clearly surrounding us. Now coming to the nature of light, what we discussed, the nature of the light is dual nature. That is, light is behaving as a ray. For example, reflection, refraction, interference, diffraction, dispersion, scattering, these all comes under ray behavior of, that is wave behavior of light, and another one is particle behavior, that is photoelectric effect is example, that is Crompton effect and Planck's constant yesterday as we discussed. That is the particle nature of light, that is light follows dual nature. Laws of reflection. What are the laws of reflection? The incident ray and reflected ray lie on the same plane at the point of incidence on either side of the normal. Then next, the angle made by the incident ray with the normal is known as angle of incidence, and angle made by the reflected ray is known as angle of reflection. Angle of incidence is represented by small I, whereas angle of reflection represented by small r. Angle I is equals to angle r. Now, we already discussed that whatever objects are undergoing the phenomenon of light, that is reflection or refraction or any phenomenon, absorption of light will be there and bouncing back of the light ray is known as reflection, whereas whenever it is passing from a transparent medium, it undergoes the phenomenon of refraction, that is at the point of interface and at the point of incidence. Interface is nothing but the layer of separation of two media. Suppose for example, air is one medium and glass is one medium. When the light is passing from air medium to glass medium, at the point of incidence, at the separation of these two media, it bends and proceeds in the next medium. This is bending of the light ray at the point of incidence and passing into the another medium and traveling in a straight line is known as refraction. The most best example for reflection will be taking as plane mirror, and it is plane mirror, most of the light gets reflected and some of the light will be absorbed in the medium. Then next, what are the characteristics of light ray? Because light is energy, it travels. So the speed of the light can be designated by small c, and it is the product of wavelength and frequency. So wavelength is lambda and frequency is nu. So speed of light is constant for a medium, and it is speed of light is approximately 3 into 10 to the power of 8 meters per second. Now reflection of light by other medium, any medium that is polished well without any irregularities on its surface, is known as regular reflection. If it is caused by a smooth reflector, it is known as regular reflection, that is plane absorbed by the surface. Laws of reflection, the main law is angle of incidence is equals to angle of reflection. Next, light undergoes those phenomena of reflection and refraction in straight line. So this propagation is called as rectilinear because it is traveling in straight path. This path describes the traveling of light from the source. Always light will travel in straight line. So this is known as property of light propagation. To follow, it has to follow one theorem known as Fermat's theorem. The principle, this is nothing but Fermat's theorem explains the principle of least time, that is within the minimum time, delta t, we will say minimum time, light always takes the quickest path. Whatever the distance between any two points, which may be shortest path or longest path, but it takes the always the quickest path in the least time. This is basing on the rectilinear propagation of light, and basing on the Fermat's theorem, angle I is equals to angle R. This can be valid by Fermat's principle of least time. So this is the derivation. See, this is the path of the light, reflected light. This is the longest distance, but even this is the direct path in between A and B. But also, which is the quickest path, that will be taken up by the light that takes the least time. This is nothing but called as Fermat's theorem. For this theorem, the first law of reflection, that is angle I is equals to angle R, can be valid. Now coming to the plane mirror. Plane mirror is any flat surface whichever is polished at one side and without any irregularities, and the other side will be coated. It is called as a plane mirror, and the surface is known as from where the light will be reflecting, that is called as a reflector. Since plane mirror surface is smooth, it is called as a smooth reflector. There are two types, real and virtual, but always plane mirror forms images, virtual images. A virtual image is that image which cannot be caught on the screen. These images are formed because of the divergence and convergence of light rays from the source. Now, if the image is formed upside down, then it is called as a real image on the screen. So, image may be bigger or smaller than the size of the object. That size, whichever describing about the image, whichever describes the image size, that is called as magnification of the image. So, if the image is smaller, we will say that it is diminished. If it is larger than the object, if the image is, it is called as magnified. So, magnified images are bigger than the object and diminished images are smaller than the size of the object. So, images are of two types. Images are of two types, real and virtual images. Real images are those images which can be caught on the screen. Usually they will be forming because of the convergence of light rays in front of the mirror, and they can be caught on the screen, and they are always upside down, that is inverted, and real images may be bigger or smaller than the object. If the image is bigger than the object, it is called as magnified image. If it is smaller than the object, it is called as diminished. And another type of image is virtual image. Virtual images cannot be caught on the screen. They are always erect. They also may be diminished or magnified. Now, or they may be equal size. So, size of the image is described by the word magnification. If magnified means the size will be bigger than the object. Image size will be bigger than the object. If it is diminished, image will be smaller than the object. Now, coming to the image formation by a plane mirror. Always plane mirror forms an image which is virtual and erect. the image and object are at equidistant from the mirror, then the size of the image will be equal to the size of the object, and the image is laterally inverted, that is right side will be seen as left side and left side will be seen as right side. Now this next is principle of reversibility. If the direction of the ray of light is reversed or due to reflection of a surface, then it will be retraces its path. This retracing of, that means in the same path it comes back, moves back, that is called as reversibility of light. Retracing, how it is going and hitting an object, again coming in the same path, it is called as retracing. In case of refraction also, from the other medium it comes in the same path back into the first medium, that is called as retracing. Whenever it is undergoing, the direction of a light ray is reversed or retraces, that is called as principle of reversibility of light. Next, coming to the spherical mirrors, there are these types of mirrors. Till now we have observed the plane mirror. Now coming to the spherical mirrors, when you are considering a hollow sphere and when you are cutting it into two, it comes into a parabolic shape. When if the reflector surface is inverse, it is called as concave mirror, and if it is bulged out, the reflector surface, it is called as convex mirror. So these are, conveniently we will be calling these spherical mirrors as curved mirrors, because slice this shell, then it becomes a curve. So this curved mirror also known as the spherical mirrors. Curved mirror is a mirror with a curved reflecting surface. The surface may be either convex, that is bulging outward, or a concave, that is inward. Most curved mirrors have surfaces that are shaped like a part of a sphere, but other shapes are sometimes used in optical devices. A mirror or any polished reflective surface or the reflector which is a curvature is known as a curved mirror. That means the shape of the mirror, when you are observing, it is like a parabolic shape. In case of concave mirrors were silvered on the inside of the sphere, whereas convex mirrors were silvered on the outside of the sphere. The important terms related to spherical mirrors are pole of the mirror. Midest point of the spherical mirror is called as pole of the mirror, that lies on the curve. Next, coming to the center of curvature, the center of the from which this spherical mirror is taken, or this spherical mirror is a part, it is called as center of curvature. Now, radius of curvature, the distance between the pole of the mirror and the center of curvature of the spherical mirror is known as radius of curvature, and pole of the mirror is designated by capital P, center of curvature is designated by capital C, and radius of curvature is by capital R, and the distance will be designated by small r. Now the line which is passing through these two, that is the point, the midest point of the curve, that is spherical mirror, that is pole of the mirror, and the center of curvature of that spherical mirror, and passing through those and extending, that is called as principal axis. And this on the principal axis, whenever inwards, it is called as concave mirror, and if it is bulging outwards, this polished surface, then it is called as convex mirror. Now, whenever some parallel beam of light is incident on a concave surface reflector, then reflected from a concave surface will be meeting at a point on the principal axis in between pole of the mirror and center of curvature. That point is known as principal focus, and it is designated by capital F. And since these are all coming and meeting at a point, that point is known as converging point, and the mirror is known as converging mirror. So concave mirror is also known as a converging mirror, and the distance between pole of the mirror and principal focus is known as focal length, and it is designated by small f. On the ray diagrams we can be following two rules mainly. One is a ray passing through the center of curvature of any type of mirror, whether it is a concave mirror or a convex mirror, it retraces its path. That means in the same path it goes back, reflects back. Next, the rays which are coming parallel to the principal axis will always passes through the focal point or principal focus, or the rays which are passing through the principal focus from the source will travel after reflection from the mirror parallel to the principal axis. This is vice versa. Rays which are parallel to the principal axis passes through the focal point, or rays which are coming from the source and passing through the focal point or principal focus, and after reflection they will travel back, reflects back parallel to the principal axis. Then the ray which is passing through the center of curvature of a mirror will always retraces. Then so you can take it as a normal. Now how the rules can be. Now how you can draw the ray diagram. See, whenever from the object, if the ray is coming parallel to the principal axis, now this is suppose the curvature of a mirror on at the point, middest point of this curve is known as pole of the mirror and is designated by P. Now then this curve from which sphere you are making it a part, that center of that sphere is called as center of curvature and is designated by capital C. The distance between this pole of the mirror and center of curvature, this is called as radius of curvature. Then whatever the rays are coming parallel to the principal axis and after reflecting converging at a point, that is known as principal focus or focal point, and it is designated by capital F. The distance between pole of the mirror and focal point or principal focus, this is known as focal length and is designated by small f. Now coming to the rules, suppose whenever a ray is coming parallel from an object to the principal axis, it always it passes through the focal point, or if the ray is passing through the principal focus, it after reflection it comes back parallel to the principal axis. So the first rule is, if the ray is parallel to the principal axis from the object, it passes through the F, or if the ray is passing through the F incident ray, then after reflection it comes back parallel to the principal axis. Next is suppose it is parallel to principal axis, it comes through the focus. Suppose it is passing through the principal focus parallel to the principal axis. So red lines here represents the reflected rays and blue lines represents the incident rays. Now next rule is are intersecting at a point. Where the intersection of point is there the image will be formed. Suppose this intersection point is before the mirror, it is a real image, inverted image. Now only whenever the ray is passing through the C, it retraces in the same path. These are the rules for drawing the ray diagrams.